All right, Chapter 2 review time. We're first going to take a look at the quiz worksheets that you all worked on in class yesterday. So number one, we had to figure out what was Sebastian's percentile. Sebastian had a score of 62, and we were told that 33 students had scores higher than 62. So we got to remember, what was the definition of a percentile? It was the percent of values that were less than or equal to. And we were told kind of the opposite direction, that 33 students had a score higher than Sebastian's 62. So if I was told up here at the top that there were 78 students altogether that took this test, I get rid of the 33 that did better than Sebastian, then that would mean that there were 45 scores that were as good or less than Sebastian's. So if I take 45 scores out of 78 in total, that gives me 0.577 to 3 decimal places. So therefore, Sebastian's percentile would be the 57.7th percentile. Now, part B, interpret his percentile. What does it mean to be in the 57.7th percentile? So I said 57.7% of students scored lower or the same as Sebastian's score of 62. And you could rewrite that lower or same as in a variety of different ways. But essentially you have to get at that this percent represents the percentage of people that did as good or worse, or Sebastian did as good as or better than this percentage of students. C, calculate Sebastian's z-score. So we got to know that z-score formula. Z equals x minus mu over sigma. X is Sebastian's score of 62. Mu is given to us. It's in this table of values here. We got to find mean, 56.85. So that's kind of hidden. There's an 8.5 back there. And the standard deviation, the STDEV, is 12.35. Once I did that math, I got 0.417. Now, part D, what does 0.417 mean specifically as a z-score? Well, a z-score represents the number of standard deviations above or below the mean. And since it's a positive z-score, then we are above the mean, right? A 62, Sebastian's score, was above the mean of 56.8, which is why we should get a positive z-score. So Sebastian's score of 62 is 0.417 standard deviations above the mean of 56.85. Really, I would be happy if you would just tell me that it is the 0.417 standard deviations above the mean. You don't necessarily have to tell me what the mean score was because it was already given in the problem. All right, next up, what is the median song length? Draw a line on the graph to show how you arrived at your answer. So the median in an ogive would be at the 50th percentile. Typically, the vertical axis is going to be the percentiles. And whatever the context of the problem is going to be your horizontal. Now, technically, it could be flip-flopped, but most of the time, percentiles is vertical. Actual values are going to be horizontal. So median 50th percentile, I would have to kind of estimate where is 0.5, because that would be the 50th. And I go over until I hit the ogive, hit the graph, drop vertically straight down. And I can see it's somewhere between 3 and 4, closer to 4 than it is 3. I estimated, I don't know, maybe it's 3.8 minutes. As long as you gave me a number somewhere around that 3 to 4 value, or depending on how you drew your lines, as long as I could see that you're coming from the 50th percentile, you're hitting the graph and you're dropping down, as long as you gave me a good estimation, then you would get the full credit for that. What is the IQR? So IQR, we got to know, is Q3 minus Q1. Q3, 75th percentile. Q1, 25th percentile. So again, I had to estimate. I kind of had to estimate where the 75th was. I could find where 0.7 is between 0.6 and 0.8. And so then I had to go in between 0.7 and 0.8 to find 0.75. So I went over, went down. I estimated it to be maybe 4.6, maybe 4.7. I don't know. I went 4.6. Then 25th percentile, had to do the same thing, estimate 0.3, then estimate halfway again to get 0.25, and I thought maybe 3.3. So I am estimating that the IQR would have a value of 1.3 minutes. So again, as long as your answer is roughly around that same answer, then you would get full credit. Number 5, what is the range of song lengths? Well, range was max minus min. The minimum value is really where the ogive starts at. It doesn't necessarily have to start in the bottom left corner. It starts, we can see it looks like slightly less than 2. So I estimated maybe that's 1.8. And then I want to see, where does this thing finally kind of plateau at? Where does it finally end? And that would be the maximum value. That's when it gets to the 100th percentile value. And so again, I estimated maybe 9.2. So I subtracted max minus min. I thought it's going to be around 7.4. Again, as long as you're close-ish, you would get the full credit. All right, number 6. According to these data, the mean song length was 4.23 minutes. Standard deviation was 1.38. Music lover who wants to create a mix of songs wants to have 5 seconds of silence between songs. So he needs to add 5 seconds to the length of each song. He also wants to express the times in seconds rather than in minutes. Calculate the mean and standard deviation of the transformed data. So there are 2 things going on in this problem. We have to add 5 seconds to every song, and we need to go from minutes into seconds. Now, really, you would kind of get to decide which order you would want to do those 2 things, okay? So I decided I'm first going to make the conversion from minutes into seconds, because if you try to add the 5 seconds on first, well, the mean and the standard deviation were in minutes. So you would first have to figure out 5 seconds is really what fraction or decimal of a minute. That kind of sounds more like a pain in the butt to do. So first, I converted minutes to seconds, which means I would have to multiply by 60. Now, we discovered that multiplication affects every kind of value in a transformed data set. So I do get to take my original mean of 4.23 and multiply it by 60 to turn it into seconds. And with the standard deviation is also affected by multiplication. So I would multiply that by 60. Then I now finally get to tackle the 5 seconds that I need to add on to each and every song. So if the mean song length is 253.8 seconds, then that will be affected by the addition of the 5 seconds. So it will move an additional 5 seconds down the line. So adding the 5 seconds on, here's my new average song length in seconds. Now, adding does not affect measures of spread, and standard deviation is a measure of spread. So I may write plus 5 seconds, but then I got to remember that has no effect on the standard deviation or the IQR or the range. So the new standard deviation in seconds is still 82.8 seconds. All right, we got Santiago in 51st place among men with a time of 20.9 minutes. Kesha, let's go Kesha. Finished 33rd among women with a time of 25.2 minutes. Did Santiago or Kesha do better relative among men and women respectively? So some people would just sit there and argue, well, Kesha obviously did better, right? She got a better place than Santiago, who was in 51st, and Kesha got 33rd. So obviously Kesha did better. But we're comparing men's scores to women's scores, or in this case, times, right? We're doing a 5K road race here. And men's and women's times are not the same. And so again, it's like we're comparing apples to oranges here. We need to standardize our times so that we can compare them to each other. So I standardized Santiago's time of 20.9 minutes. I had the mean. Here was the mean for the men and the women. And the standard deviation is right next to it. So I got to use those means and standard deviations with my z-score formulas, and I found that Santiago's z-score was negative 0.7676, and Kesha's z-score was also negative, but 0.5695. So both of them, and we got to remember, in terms of race times, smaller is faster. So since they are both negative z-scores, that means they were better than average. But who was further away from better than average, meaning that they were faster and better? Well, technically, Santiago is further away from the mean of 0 than Kesha is. So even though Santiago got 51st place, if we were to kind of compare ultimately the men and the women in terms of z-scores, Santiago's time is relatively better than Kesha's. All right, number 8. Now we get into some normal distribution problems. So elite distance runners' body weights follow an approximately normal distribution. We got a mean of 63.1 kilograms and a standard deviation of 4.8 kilograms. So a lot of what we're doing is we're going to get to use normal CDF and inverse norm. The number one prerequisite to using normal CDF or inverse norm is you have to be told that you have a normal distribution. If they do not say anything about the distribution being approximately normal, or if they specifically say, elite distance runners' body weights follow a skewed left distribution, you can't use normal CDF for a skewed left distribution. There is no skewed left CDF. There is no skewed right CDF. I mean, you can calculate them, but it's much more advanced to figure that out. So, what proportion of runners are between 48.7 and 67.9? So I drew a little picture, drew my mean in the middle, 48.7 is below the mean, 67.9 is above the mean, and I'm being asked what is that percent, basically, between that number and that number. And that's exactly what normal CDF would tell us, what that percentage or that proportion of values is. So I plug that in. You notice I've got my labels here. I wrote out the name of the calculator command. That's definite points right there, the name of the command and labeling what all those numbers represent. And I got right at 84%. I mean, it was like 0.8399 something. Now, some people may have noticed that 48.7 is an exact number of standard deviations below the mean. I believe it's 3 standard deviations below the mean. And 67.9 is exactly 1 standard deviation above the mean. So if I were to use that 68, 95, 99.7 rule, then I would have gotten an answer of 83.85% instead. Both of those would be considered correct answers. But I would imagine, for the most part, most of you are just going to go automatically to the normal CDF. All right, number 9. What proportion of runners have body weights below 60? So mean in the middle, 63.1, 60 is below that. I want to go below 60, so I'm shading everything below it. And I get to use normal CDF again. I got a lower bound, negative infinity, realistically 0. So either one would get you the same answer. Upper bound 60, mean and standard deviation values, and I get just under 26%, right? 25.92%. Now, the other thing I would mention here that we can tie in is that technically, since we went less than or equal to 60, then the answer that we got here really represents a percentile. So we could say a runner who had a body weight of 60 kilograms would be in the 25.92nd percentile. But remember, not all proportions or percentage answers from normal CDF represent percentiles. It's only if we go less than or equal to all the way down to negative infinity or all the way down to the left end. Number 10, how many are above 70? So now we're on the right side of the curve, so 70 and up. And I get about 7.5%. Now, this is like what I was just mentioning. Can we say that a weight of 70 kilograms is at the 7.5th percentile? No, because that's going in the wrong direction. Percentile must go less than or equal to. So we could take our answer and subtract it from 1 or 100%, and then that would tell us what the percentile value would be for 70 kilograms. All right, number 11. Approximate the mean, median, and standard deviation of the normal distribution graph below. Now, since we have a normal distribution and it's symmetric, the mean and the median would have the same exact value. So if I can find where the mean is, just drop straight down the middle here, I would see that it looks like it's at about 150, right? The median, it's going to be the same thing. Now, the standard deviation, I showed you a couple different ways to estimate a standard deviation. We could, number 1, we could go halfway down. This looks about halfway down the curve, and then back up a little. And then you could say, all right, that is maybe roughly about a standard deviation. I don't know. Was that about halfway down? I don't know. Maybe like right here. Maybe that's halfway down and then back up a little. And then you go, all right, from 150 to what? 240, 230 maybe, then we could estimate that a standard deviation is maybe 80, 90. But the other thing I showed you was if we were to kind of look at all the way across would be about 6 standard deviations. We could go 3 above and 3 below, and that captured 99.7% of our data. So I only really looked at half of that. I don't have to go across all 6 standard deviations. What if I started at the mean and then went up towards the end? Now, I don't have to go all the way to the 450. I decided that maybe 3 standard deviations. I just kind of stopped and estimated and said, hey, 400, that looks like a far enough up above the mean number that we'll call that 3 standard deviations. So how much distance was there between 150 and 400? Well, that covers about a distance of 250 units or points or whatever the score is in. And so I took that 250 and I split it up amongst the 3 standard deviations that it's technically going above the mean. And so I estimated that maybe it's around 80, 83.3, I think is what that would come out to be. But really, if you gave me any number between like 80 and 100, I think that would be a good, reasonable standard deviation value. All right, 12. What percentile would Jada be in if she scored a 42? We got a new type of problem here. We got a new type of test. It's approximately normal with a mean of 100 and a standard deviation of 15. So I know I can draw a normal curve. I told it was approximately normal. That unlocks by default normal CDF and inverse norm as being possibilities. The mean in the middle's at 100. Jada scored a 42. She is well below the mean. We could figure out roughly how many standard deviations 42 would be below 100 if a standard deviations were 15, but I'm just going to go it's somewhere pretty far down. So I just marked 42. Percentile by definition, remember, is less than or equal to. So I want to shade less than 42. And if I want to know percentile, I need to find area. So normal CDF. So 0 realistic lower bound, theoretical negative infinity. We want to go up to 42. 100 for the mean, 15 for the standard deviation, and you might freak out the first time that you saw that number because it was going to say something in scientific notation, probably 5.519 times 10 to the negative fifth power. And so it's perfectly fine to write your answer in scientific notation. That works out. Since I asked for the percentile, then I moved the decimal point over 2 to the right, and then I wrote that number percentile. I would be perfectly happy with this number, with the scientific notation answer, or if you actually want to tell me a percentile, just make sure that you interpret it correctly. 13. What minimum score would represent the top 1%? Top 1% is going to be all the way down here on the right, but I got to remember, most of our calculators, now the ones I've got in my classroom, the newer ones, you can tell it which direction that you want that 1% to go in. But normally I would say the top 1% really means we're in the 99th percentile. So I want to use inverse norm. If I have an area, if I have a percentage, that's normally what normal CDF would give me, but this is the opposite. The opposite of normal CDF is going to be inverse norm. So if I put in the 99th percentile with a mean of 100, standard deviation of 15, then this tells me what that minimum score would be to be in the top 1%. You would have to score at least a 134.9. Now again, if your calculator has the left, center, right option, you would do 0.99 left, but if you did 0.01 as the percentile, then you would tell your calculator, this is kind of hard to write with the mouse, you would say 0.01 to the right, and it would give you the same exact answer. All right, Billy's score places him at the 42nd percentile. 42nd percentile. We're going to be using inverse norm. That's kind of the area in this situation. So I want to know what number, what score would that represent? So inverse norm, 0.42. Same mean, same standard deviation. And we get that it's about a score of 97. And the last one, number 15. What is the IQR of all scores? Again, IQR is not going away. We did a lot chapter 1. We're still doing it a lot in chapter 2. So IQR, Q3 minus Q1. Q3, 75th percentile. Q1, 25th percentile. Since we're still dealing with percentiles, we still get to use inverse norm. So I figured out that Q3 was a score of 110.12 rounded. 25th percentile, 89.88 rounded. What's the difference? it's a little over 20. So as long as you gave me something, 20.24, 20.2, 1 to 2 decimal places, that works out perfectly fine. All right, so that's all for the quiz worksheet that you guys worked on. Now let's look at some other problems as we continue to review. All right, a couple questions from the multiple choice practice the other day that I wanted to go over, really on the uniform density curves. And I know a lot of this chapter we spent time doing normal distributions, but we did talk about uniform distributions, which essentially are just a rectangle. And regardless of whatever type, shape distribution we had, one of the main properties that works for all distributions is that the area underneath the curve has to be 1. So for problem number 1, for this density curve, what must the value of x be? And x is really the length of the base of that rectangle. So keeping in mind that the area has to be 1 for this rectangle, and the base is really equal to x, and the height is really equal to 2/5, or you could write it as 0.4 if you wanted to. So we got to figure out 2/5 times what? Base times height has to equal 1. And if we multiply by the reciprocal on both sides so that we can get rid of the 2/5 with 5/2, well, 1 times 5/2 is 5/2. 5/2 as a decimal is 2.5, which is why the answer for x must be 2.5. Then for number 2, it took it one step further, and you didn't really need to know that x was 2.5 to be able to do number 2. But it said what percentage of the observations lies between 0.5 and 1.2. So I just roughly estimated where I thought 0.5 was, and I roughly estimated where maybe 1.2 is, and then I went up the curve and kind of marked off these regions, and we wanted to know the area in between. So really I've got an area of a smaller rectangle. So I'm still going to do base times height. Now what's nice is the height is still 2/5 or 0.5. But the base, how much distance is there between 0.5 and 1.2? Well, there's 0.7. Now, this makes a little bit more sense if I call 2/5 0.4, so that now if I do basically 70% times 40%, that would give me 28% altogether. So there will be some questions on the Chapter 2 test that focus on uniform distributions. So just remember, the area is 1, and you just get to go back to your easy geometry days of base times height for these types of problems. All right, now I've got some other multiple choice style questions. So it says a data set of test scores is being transformed by applying the following rule to each of the raw scores. The transform score is equal to 3.5 times the raw score plus 6.2. Which of the following is not true? All right, so if I take a look, what are they wanting me to kind of focus on here? So they gave me specific, looks like measures of center and measures of spread to consider. And I want to see what those values do under this type of transformation. So first I got to realize there's multiplication involved in this transformation. And I got to remember multiplication affects every type of value. Measures of center, measures of spread, positional values, everything is going to be affected by this multiplication. And you'll notice everything in every single one of these things is affected by the multiplication. But it's going to come down to the other part. There is also addition going on in here. And addition only affected, or here, let's do this. It does not affect measures of spread. So standard deviation, there we go, IQR, and range. So when it talks about the mean being transformed by multiplying the old mean and adding 6.2 on, that would be true. We would do that. We would multiply and add the old mean to get to the new mean. And we would do the same thing for the median, right? Median's a measure of center. It would be affected by the multiplication and the addition. Range is a measure of spread. There's the multiplication again, but, do we just said that measures of spread are not affected So I think this one is the not true statement here, but let's look at the rest. Standard deviation. So there's another measure of spread, but here it only talks about doing the multiplication. And for IQR, it talks about also only doing the multiplication. It does not try to put in the addition. All right, so it is, in fact, answer choice C. Next multiple choice question. A distribution of scores is approximately normal with a mean of 78 and a standard deviation of 8.6. Which of the following equations can be used to find the score x above which 33% of the scores fall? So whenever I look at these answer options here, they kind of look familiar to me, like, oh, I don't know, kind of looks like z-scores. So if they are leading me into believing I need to use a z-score formula, z was equal to x minus mu over sigma, right? And we can see each one of those has an x minus, x minus, x minus, x minus, and they all have x minus 78s, and the mean was given as 78. So that really does look like it's lining up to be a z-score formula. Now, I need to divide by just the standard deviation, right? And the standard deviation was 8.6, but in this one, they're squaring it, and that one, they're squaring it. So I know it's not A and it's not B, but everything else, C, D, and E, is all about x minus mu over sigma. So now I got to decide which one of these is really the correct Z. Now, I would say the most common, one of the two most common incorrect answers is actually E. And people would go 33% fall above it. So what, 67% fall below it. So I could see some people identifying, well, it's got to be E. Or I could see some people saying the answer's C because there's the 0.33, right? And I think most people would probably conclude it definitely can't be D because where on earth does 0.44 come from? That doesn't seem like a plausible number at all. But the trick to this is we need a z-score, right? And saying that we are 33% above or 67% below is not a z-score. So how do we actually get a z-score out of that 33% above or, on the flip side, 67% below? We would need to use inverse norm to figure that out. So if 33% is above, then again, 67% is below. So if I did inverse norm 0.67, and then this is where some people would go, all right, well, we know a mean and we know the standard deviation. So let's do 78 and 8.6. And I would say you could do that, but what you're going to get is the actual percent score that's at the 67th percentile. And we don't want the actual score. We want the z-score. And so the z-score would mean that we would need to use 0 for the mean and 1 for the standard deviation. So let's grab our calculator here. Let's see, calculator, where are you at? There we go. So if we went second variables, went down to number 3, did 0.67, 0, 1. Now, I could do 0.33 and say the tail is to the right because that would be 33% above. And then we go down to paste, and lo and behold, there's that 0.44 that we saw. So it is actually answer choice D. And I would say this is definitely a commonly missed multiple choice question. Because again, some people just want to instantly dive in and look at either the 33 or the 67. But again, neither of those represent actual z-scores. So to be 33% above, we have to be 0.44 standard deviations above the mean in order for that to happen. All right, next one. Distribution of heights of 6-year-old girls is approximately normally distributed with a mean of 46 inches and a standard deviation of 2.7 inches. Aaliyah is 6 years old, and her height is 0.96 standard deviation above the mean. Her friend Janie is also 6 years old and is at the 93rd percentile of the height distribution. Awesome. At what percentile is Aaliyah's height, and how does her height compare to Janie's height? All right, so at what percentile is Aaliyah's height? Well, we were told Aaliyah, her height is 0.96 standard deviations above the mean. So to say it's that many standard deviations above or below the mean, that is her z-score. So z equals x minus mu over sigma. We could, say this is 0.96, and we could actually figure out what is her actual height, right? That's what we're trying to figure out, x. Minus 46 over the standard deviation, 2.7, and we could do the algebra and figure out what her height really is. But her height isn't her percentile, though, right? So we could do this and then figure out, the percent that fall underneath that particular value by using normal CDF. I guess that is a strategy we could do here. But in the grand scheme of things, we don't have to go that far. If her z-score is 0.96, then consider if I had a standard normal curve with a mean of 0 and a standard deviation of 1, then Aaliyah is just below 1, right? She's at 0.96. Z equals 0.96. And her percentile would be the percent of all values that fall below her. So really, I could do normal CDF with this. Normal CDF, lower bound, negative infinity. I wouldn't do 0 because 0 is the mean on our standard normal curve. Up to 0.96. And then again, we're doing the standard normal curve here. So let's see, what does that come out to be here? So second, variables, normal CDF, negative 99999, upper 0.96. We leave it at 0 and 1. And so 0.8315, 0.8315, which means she is in the 83rd.15th percentile. So Aaliyah's height is in the 17th percentile? Nope. Aaliyah's height is in the 67th percentile? Nope. 67th? Nope. 83rd? Yeah. 83rd? Yeah. Now, is she shorter or taller than Janie? Well, Janie was in the 93rd percentile for height. So in this scenario, does bigger mean better? Does bigger mean taller? And yes, it does. So Aaliyah is shorter. She has a smaller percentile than 93rd compared to the 83rd. So I would say the correct answer is D in this scenario. All right, one more multiple choice problem to take a look at here. It says the heights of adult women are approximately normally distributed with a mean of 65 inches and a standard deviation of 2 inches. If Rachel is at the 99th percentile in height for adult women, then her height in inches is closest to which of the following here? So one thing just to kind of consider here. We are told the shape is approximately normal. We know the mean in the middle is at 65 inches. Standard deviation, we can kind of play, and go, there's one standard deviation, there's two standard deviations, there's three standard deviations. But I really don't need to know that specifically. But for Rachel to be in the 99th percentile, that means 99% of other women's heights are less than or equal to hers. So she is way up here on the right end. Like, let's say right here, here's where Rachel is at. So that below her are all of these other shorter women compared to her. So again, this represents 99% of all other women. So I know for sure Rachel, she is way above the mean, right? So when I look at my answer choices here, is there any possible way Rachel could be 60 inches tall? That would mean that she'd be below the mean. So no. Could she be 62 inches tall? Absolutely not. That would mean that she's below the mean. 68 inches tall. Well, at least now that's above the mean. 70, it's above the mean. 74, it's above the mean. Now, some people would argue, let's just pick the biggest number, right? Because 99, that's so far away, it's got to be the biggest number. But how do we actually figure this out in here? Well, this is just a matter of an inverse norm problem. This wouldn't be a normal CDF. Normal CDF would give us the 99% number as the answer. But if we're wanting to know on this kind of horizontal axis of heights, we want to know what is a specific number, then inverse norm is what's going to tell us that. So inverse norm percentile, 99%, really to the left. Remember, if you have a calculator that has left, center, right, you could do 0.01 to the right, and it would give you the same answer. But we're going to go by default here. The area or the percentile would be 0.99, and we're given the mean, and we're given the standard deviation. So if I were to type that into my calculator, let's see, number 3, let's go 0.99. We said 65 was the mean. 65. And 2 was the standard deviation. We're going to leave that as left. And we're, just a smidge under 70 inches. So which one is closest to? Well, technically that'd be answer choice D would be the closest, not actually the 74. All right. The last thing that I have here for you are optional study sources. There are practice worksheets at the end of your note packet with answers that follow, so you could try some additional free response style questions. And there's also the bonus multiple choice review video, which is at the end of your note packet. There's the solutions, and I'm also going to post a video solution so that if you try those problems out, you discover you missed some, you could fast forward through the video, and then you could watch specifically those questions that you really need. So good luck studying, and hopefully we have better results on the Chapter 2 test.